Hello my friends and welcome back to the You Can Do TV channel.
At Liberty Steel Dalzell, the steel manufacturing process combines expertise and modern technology to ensure high-quality production. It begins when customers place orders detailing size, thickness, and performance requirements. Certified raw steel slabs arrive at the rolling mill, where they are logged, tracked, and cut to size. Expert operators manage temperature, timing, and pressure, ensuring precise rolling. The steel is then cooled to achieve the required strength and internal structure. After rolling, plates are hard stamped for traceability and pass through trimming, leveling, and final inspection. If needed, further processing like quenching and tempering is done at Clydebridge. Before leaving the factory, all steel undergoes rigorous quality testing and certification. With a commitment to sustainability, Liberty Steel Dalzell delivers premium metal while maintaining an eco-friendly, secure supply chain.
Quantum of the Seas is a quantum-class cruise ship with an overall length of 347 meters. It is currently operated by Royal Caribbean International and is the lead ship of her class. At her time of delivery in 2014, Quantum of the Seas was the third largest cruise ship in the world by gross tonnage with dimension of 167,800 GT. The ship is applied a special process, the so-called laser hybrid welding. The benefits of using a laser in steel construction are higher speed, less warping due to limited exposure to heat, improved strength, and the associated considerably lower costs in comparison to traditional welding techniques. Shipbuilding process operates according to the building block principle. Sections are made from steel sheets and blocks are made from sections. Usually, approximately 70 blocks, weighing up to 800 tons, make up a ship. The technical equipment is also pre-assembled wherever possible before it is added to the ship. Thanks to the modular design made up of individual, pre-manufactured blocks, the ship can be built within a short time. The 600 and 800-ton cranes enable a high degree of flexibility in the preliminary installation of the blocks. The blocks are built and pre-fitted right next to the construction dock. Then they are moved to the dock with the crane and welded to the ship.
The SMS Group 8100ths of a mega-Newton open-die forging press at Dongbei Special Steel is designed for precision and efficiency in forging high-quality steel components. The process starts with heating an ingot up to 1,250 degrees Celsius before it is transported by crane to the forging area. A manipulator then positions the ingot in the press, which applies an upsetting force of 100 meganewtons and a press force of 80 meganewtons to shape the material. The machine operates with a maximum stroke rate of 88 per minute and forging speeds of up to 170 millimeters per second using a single cylinder. With a cylinder stroke of 3,500 millimeters and a table travel distance of 9,000 millimeters, the press accommodates large-scale forging operations. Its automated synchronization of movements ensures efficiency, and with an annual capacity of 65,000 tons, it is a reliable solution for producing tool steel, stainless steel, and structural steel components for industrial applications. The press works by stretch forging the hood section to form a gripping neck, followed by reheating and upsetting to refine the structure. The workpiece is then shaped into a square and further forged into an octagonal profile. The system ensures plus or minus 1 millimeter forging precision, enhancing uniformity. The production of a crankshaft at ALFING represents an industrial process shaped by strength and experience. It begins with closed die forging, where heated steel ingots are transformed under counterblow hammers and powerful presses exerting up to 500 tons of force. The scale of energy at this stage is immense, and every strike reshapes the raw block into a recognizable form. The thunderous rhythm of hammer blows conveys a sense of raw industrial might. Watching the red-hot steel being compressed is both intimidating and fascinating at the same time. Pre- and intermediate machining follows, performed on advanced CNC turning and milling machines. Integrated measurement systems ensure geometry is maintained during rough shaping. The combination of power and accuracy feels impressive here. Each transition between machines shows how seamlessly the process is connected. The interplay between digital control and heavy metal cutting underlines how tradition and technology coexist. Heat treatment is next, applying induction hardening or stroke peening to increase surface strength. Each method enhances durability against fatigue, an essential property for engine performance. The glowing steel during hardening leaves a striking impression of resilience. It is a visual proof that durability is engineered, not just expected. Material testing accompanies these steps, including magnetic particle inspection, bending and torsional fatigue tests, and residual dirt analysis. These controls secure reliability for every unit. The thoroughness of verification truly inspires confidence. Finishing operations then refine the part. Multi-stage machining, shot peening, and dynamic balancing bring tolerances down to as little as 1/1000th of a millimeter. Laser coating and automated measuring systems finalize quality checks. At this point, the crankshaft carries both engineered precision and physical strength. The exactness of these final touches gives the component a sense of completeness, ready to serve in engines worldwide. In the clean room, washing, preservation, and packaging are conducted to prepare for shipment. Each shaft leaves the factory ready for installation. Hanapech.
Cutting steel like this isn't for the faint of heart. Using a Union PC 150, machinists perform helical milling on a 12 inches deep weld bevel, tapering from 16 inches to 32 inches diameter at a 30 degrees angle. A 6 inches toroid cutter handles the precision work.
The first ship of the Quantum class sets new standards in terms of eco-friendliness. It features highly energy-efficient systems, optimized hydrodynamics, heat recovery, an effective underwater paint coating, a state-of-the-art exhaust gas treatment plant, hybrid scrubber, as well as energy-saving LED lighting systems. As to interiors, the Quantum leaves nothing to be desired. 4,180 guests can be accommodated in 2,090 cabins, and are taken care of by a crew of approximate 1,550. Sophisticated alarm, safety and communication systems combined with the latest technology in propulsion and navigation are typical for Royal Caribbean cruise ships. The same high standard applies to entertainment and interiors.
A colossal Conroe vessel, the M/V Marjorie C, slides into the water at VT Halter Marine. Engineers and shipbuilders coordinate precisely, ensuring a safe launch for this hybrid container and roll-on/roll-off ship.
Watch a 3.4-meter steel dome take shape. It's intense. The process starts with the dishing machine, pressing a flat disc into a hemispherical shape. As the press drives down, thousands of tons of force are applied evenly across the surface. Then, it's moved to the flanging station, where the edges are gradually curved upward. Once shaped, it's removed and inspected. These vessel heads, 3,400 millimeters wide and 35 millimeters thick, are essential for high-pressure industrial tanks.
North Shore Steel utilizes the MAV 3-roll variable axis plate rolling machine to manufacture pressure vessel components. The process begins with material preparation, where high-quality steel plates are cut to the required dimensions. The plates are then fed into the MAV 3-roll machine, which gradually bends them into precise cylindrical shapes. This involves pre-bending to minimize flat ends, controlled rolling through multiple passes, and precise alignment. Once shaped, the sections undergo advanced welding to join longitudinal and circumferential seams, followed by non-destructive testing to ensure structural integrity. Final quality assurance includes dimensional inspections and pressure testing. The integration of MAV 3-roll technology enhances precision, efficiency, and reliability in pressure vessel production, ensuring compliance with industry standards and delivering high-performance steel structures for various applications.
A stream of fire and molten energy defines the beginning of steel casting. Inside the foundry, the process connects centuries-old knowledge with modern engineering. Each sequence reveals not just technical skill but the shaping of one of industry's strongest materials. It is striking how raw heat becomes controlled progress in this space. The journey begins with pattern making. Wooden or resin models are constructed to represent the final casting's shape. These patterns guide the creation of sand molds and allow accurate replication of design. Even the smallest features must be captured at this stage, as they later influence the strength of the part. The care invested here sets the tone for the entire process. Molding follows as specialized sand is packed around the pattern. Binders are added to create a stable structure capable of holding molten steel. Afterward, the pattern is withdrawn, leaving a cavity identical to the intended shape. There is always a sense of suspense when the mold is opened, revealing the space where steel will eventually flow. Next comes melting. High-capacity furnaces transform solid metal into liquid steel at temperatures exceeding 1600 degrees Celsius. Alloying elements are introduced to achieve required mechanical properties. The glow of the furnace makes the atmosphere intense, as if raw energy is being forged into durability. Pouring then takes place. Molten steel is guided carefully into the prepared molds. Speed and flow must be balanced to avoid defects or trapped air. In this moment, timing and control decide the success of the casting. The molds are then left for cooling, allowing the steel to solidify with its intended shape. After cooling, shakeout begins. The sand mold is broken apart to reveal the rough casting inside. Excess sand is removed, and runners or risers are separated. It feels almost like uncovering strength hidden beneath layers of earth. Heat treatment follows, where the casting is reheated and cooled under controlled conditions. This step enhances hardness, toughness, and resistance. Machining comes next, with cutting tools refining dimensions, drilling holes, and shaping surfaces. Watching a massive casting being refined into precise geometry shows the harmony of raw power and control. The process concludes with inspection. Castings are examined using visual checks, dimensional measurements, and sometimes ultrasonic or radiographic testing. Only when standards are achieved can the product move forward. Each inspection carries the weight of responsibility, ensuring safety for structures that will rely on this steel.
Explorer yachts are built using advanced engineering and meticulous craftsmanship to ensure durability and comfort, even in challenging conditions. At the shipyard in Antalya, Turkey, two new Sea Explorer models, the 58 and 60, are currently under construction. The process involves highly specialized teams of naval architects, engineers, and designers, who work in close coordination with headquarters in the Netherlands. Regular quality inspections and design adjustments keep each build aligned with the intended performance and aesthetic goals. Construction of these yachts utilizes a modular approach, assembling the vessel from large steel and aluminum blocks. Each block is fabricated separately, with structural components, such as the engine room and superstructure, constructed in distinct sections. This block-by-block process, carefully managed to stay within crane capacity limits, enables efficient handling and precise placement, ensuring that each yacht's core structure is robust and well integrated. One of the defining features of these yachts is their ice-class hull, designed with reinforced steel plates and additional supports for navigating through icy waters. These hulls are engineered to withstand specific ice pressures, adding an essential layer of strength for Arctic and Antarctic voyages. Distinctive design elements enhance functionality and aesthetics, such as vertical bows and certified helipads that accommodate large helicopters, allowing for safe, remote area operations. The Sea Explorer 60, set to complete in 2024, will feature hybrid propulsion, a range exceeding 5,000 nautical miles, and ample storage for guests, tenders, and equipment, reinforcing its capability as a self-sufficient, long-range explorer yacht. The construction of the Yacht Haven began as computer drawings nearly a year and a half ago and has now transformed into a physical masterpiece. The build, handled by the experienced team at Lursen, focused significantly on creating expansive exterior spaces rather than maximizing interior volume. This choice set Haven apart from past designs, with features like a 30-meter-long sun deck that serves as a primary entertainment area, particularly for evening gatherings. Despite challenges and other complexities, construction progressed smoothly, reflecting the team's skill and long-standing collaboration. The yacht's sea trials proved highly successful, with Haven demonstrating impressive stability, quietness, and exceptional performance. Every Carnac boat begins with a concept on paper, designed by the company's team of skilled designers and engineers. Using advanced CAD/CAM, computer-aided design and manufacturing technology, designers craft 3D models with precision, defining every line, edge, and curve to enhance the boat's aesthetics, functionality, and performance. Carnac's emphasis on multi-purpose functionality means that each boat design is meticulously analyzed and refined to achieve a versatile layout. The design team uses CAD software to visualize complex shapes, ensuring every inch of space is used optimally. This planning phase also includes rigorous simulations to predict performance and structural integrity. Once the digital design is complete, the in-house 5-axis robotic milling machine produces physical prototypes with extreme precision, down to fractions of a millimeter. These prototypes are used to create negative molds, which are essential for the next production steps. Once the design and physical models are approved, the facility moves to create the necessary molds for production. Using the 5-axis robotic milling machine, negative tooling is fabricated to capture every detail of the design, ensuring each component's precise replication. The negative tooling molds then undergo finishing processes to prepare them for closed mold injection, a method that enables highly controlled material application. The facility employs an all-composite construction approach, a sophisticated technique that enhances durability while eliminating potential vulnerabilities associated with traditional materials like wood. In this phase, computer-controlled lamination ensures precision and uniformity in applying layers of composite materials. Closed mold injection technology plays a critical role here, allowing for exact control over resin distribution and minimizing emissions, which is both environmentally friendly and enhances structural integrity. Continuous production data recording further aids in monitoring lamination consistency, ensuring that each layer contributes optimally to the hull's rigidity. One of the distinct features is the foam-injected hull structure. By injecting foam into specific areas within the hull, engineers create a high-density core that provides both buoyancy and impact resistance. This method also contributes to soundproofing, making for quieter operations on the water. In the assembly stage, key boat components are precisely aligned and installed following a detailed, step-by-step operations guide. The movement of each part is monitored in real time, allowing engineers to identify and address any issues immediately. The hull and deck sections undergo permanent joining and bonding using specialized adhesive materials that eliminate the need for mechanical fasteners. This method not only increases the boat's structural coherence but also enhances durability by providing a seamless, watertight finish. The facility's emphasis on structural rigidity means that each hull is designed to withstand extreme stress without flexing. The foam-injected stringer system reinforces the hull, providing stiffness against flexure and torsion. This characteristic allows Carnick boats to maintain shape under the pressure of high-speed water impacts, ensuring reliable performance and longevity. Once the hull deck structure is bonded, the facility focuses on installing the interior components, such as seats, dashboards, and storage compartments. With efficiency at the core of the process, self-locking shapes are integrated into the design, simplifying the installation of components like fuel tanks. The ergonomic layout prioritizes usability and comfort, embodying the company's dedication to product style and detail. Precision is further maintained by the step-by-step operation instructions and controls, which provide consistent guidance for every installation phase. At every stage, the facility maintains strict quality controls to uphold its standards for durability and performance. Throughout the production process, a real-time production status monitoring system tracks every operation, ensuring compliance with design specifications. Quality is not only controlled but autonomously monitored, with more than 150 control points within each production line. This system allows the facility to identify discrepancies immediately and implement corrective measures before assembly continues. A computer-guided final quality check ensures each component meets the strictest quality standards, from structural integrity to finish. This system detects even minor deviations from specifications, allowing the facility to maintain high build quality. After the final assembly, a prototype undergoes extensive testing in various water conditions to verify performance. This phase is critical as the facility subjects the prototype to real-world stresses, ensuring it meets high safety and quality standards. If necessary, further refinements are made before the boat is approved for mass production. Each Carnick boat that hits the showroom is a meticulously crafted and tested model, identical in quality to its prototype. The construction of Kismet, a 122-meter superyacht, reflects German craftsmanship and engineering excellence, all under the supervision of the esteemed Lürssen shipyard. Beginning in late 2020, the project initially bore the code name Project JAG. It was meticulously crafted to meet Lloyd's Register standards, ensuring the vessel's structural integrity and compliance with international maritime regulations. Over approximately 3.5 years, the superyacht evolved from a keel-laying ceremony to the fully completed vessel, departing through the Kiel Canal in spring 2024. Kismet's foundational structure is built around a robust steel displacement hull with an aluminum superstructure, enhancing both stability and weight management, crucial for a yacht of this scale. The vessel spans 5 decks with an impressive internal volume of 4,900 gross tonnage, enabling a wide range of luxurious amenities and technical systems without compromising her sleek profile. Throughout construction, the integration of advanced hybrid technology underscored Lürssen's commitment to innovation and sustainability. The yacht's hybrid powertrain enables a full electric cruising mode, setting Kismet apart among superyachts for her energy efficiency and environmental consideration. This sophisticated propulsion system underwent rigorous testing to ensure seamless operation, allowing silent cruising at low speeds. Each aspect of the construction process emphasized both form and function. The bow was precisely engineered with a sharp, wave-piercing design, accentuated by a unique figurehead, a jaguar statue crafted by Aratex in Taiwan. Flared wings on the mast were added to maintain an aerodynamic profile, reflecting the owner's aesthetic vision while enhancing navigational performance. The shipyard's attention to detail extended to every feature, from mosaic-lined spa pools to panoramic outdoor decks, all structurally integrated into the hull and superstructure to endure various marine conditions. The result is a vessel where technical excellence and aesthetic refinement meet, ready to redefine luxury yachting on the world's oceans. Stacer plate boats are built to withstand tough marine conditions, making them a favorite among blue-water fishermen and boating enthusiasts alike. The construction of these boats takes place at the extensive manufacturing facility in the Gold Coast's Marine Precinct, covering over 10 acres. This factory produces more than 70 different Stacer models, ranging in size from 2 to 7 meters, with a capacity to manufacture up to 20 boats daily. With over 2,000 boats constructed annually, the factory is highly efficient and dedicated to delivering durable, high-quality boats. The construction process of a plate boat is rigorous, involving over 500 meters of welding for each boat. This extensive welding, conducted by skilled welders, is essential for ensuring the durability and structural integrity of the vessels. The boats use marine-grade aluminum, which offers excellent corrosion resistance, strength, and longevity in saltwater environments. The boats feature a robust 5 mm bottom sheet, providing a solid base that withstands impacts and harsh conditions on open water. Additionally, an internal subframe rib structure further reinforces the vessel, enhancing stability and rigidity, a vital aspect for safe and reliable blue-water fishing trips. Commitment to quality is evident in manufacturing process. Innovative equipment such as plasma cutters and a 750-ton press ensure precision in every cut and component. Plasma cutters allow for accurate cutting of aluminum sheets, while the press shapes these parts with high precision. This attention to detail is reflected in each model, with every boat undergoing multiple quality control checkpoints throughout production. These checkpoints are strategically integrated into the assembly line, holding each team accountable and ensuring that every boat meets the company's high standards. A standout feature of the boats is the Revolution hull, a design element that has become a hallmark of the brand. Initially introduced on models like the Seamaster, Crossfire, Assault Pro, and Wild Rider, this innovative hull design is now available on additional models, including the Rampage, Outlaw, and Searunner. The Revolution hull enhances several key performance aspects, making the boats highly desirable for a range of marine activities. It features a raised chine, which provides improved open water handling and stability, as well as a concave bottom sheet that allows for a smooth and efficient glide over the water. This hull design significantly improves the boat's handling and ride comfort, allowing for better performance even in choppy conditions. Additionally, the boats are designed with practical features aimed at enhancing durability and functionality. Rubber gunnels are incorporated to provide extra protection when docking, preventing damage to the boat's sides. The plate-style side sheets not only add strength to the vessel but also contribute to a sleek and modern aesthetic. The increased internal space of the boat is another advantage, offering more room for fishing equipment, passengers, and other essentials, which is particularly beneficial for extended trips on the water. Sea Hunt boats, known for their superior quality, durability, and innovation, have been a leading choice in the marine industry since the company's founding in 1995. Built from the ground up with a passion for craftsmanship and family-friendly functionality, each Sea Hunt boat transitions from raw fiberglass to a fully equipped vessel in their state-of-the-art manufacturing facility. The production process begins with commitment to comfort and control, evident in the hull design. Every boat starts with a carefully crafted mold created from a custom-built wooden plug. The mold becomes the foundation for each Sea Hunt boat's hull, which is engineered for stability, handling, and a dry ride. The distinctive true Carolina bow flare and sharp entry deadrise are hallmarks of the hulls, giving these boats an edge in performance and maneuverability. The hulls offer more running surface per foot than most competitors, allowing the company to provide a smoother and more stable ride, even in challenging conditions. In terms of material quality, Sea Hunt's collaboration with independent boat builders ensures access to top-quality materials. Their boats are constructed using composite materials, such as Nida Core polypropylene honeycomb for floors and load-bearing sections, which add strength without excessive weight. In high-stress areas, they use Nylaboard recycled fiber blocks, and Kusa composite Blue Water Series boards make up the transom for exceptional durability and strength. These materials, carefully selected and tested, guarantee that every Sea Hunt boat is sturdy, reliable, and built to last. Throughout the production process, the team emphasizes craftsmanship and innovation. The factory is outfitted with an in-house tooling shop that allows the team to refine designs and produce upgrades efficiently. The tooling shop operates continuously to ensure that designs are optimized for performance and comfort before being released. The interior elements of a boat are as meticulously crafted as the hull. Each vessel is customizable, with a variety of gel coat color options that include UV inhibitors to keep colors vibrant for years. Upholstery options are offered in white, tan, or gray, with premium upgrades available for enhanced durability and a luxurious feel. The company uses an abrasion-resistant Oasis topcoat on upholstery to ensure longevity and easy maintenance. For onboard electronics, the facility partners exclusively with Garmin, providing customers with industry-leading navigation and fish-finding technology for a complete, hassle-free experience. One of the standout features of the boats is the Ultra Entertainment Center, designed to make time on the water as comfortable as possible. This center includes high-quality Korean countertops, a freshwater sink, a wine glass rack, dual phone chargers, and ample storage. Thoughtfully engineered to balance aesthetics and functionality, the entertainment center is just one example of the family-friendly design that defines Sea Hunt boats. Finally, dedication to delivering value is evident in their rigorous construction standards and commitment to longevity. Every boat is NMMA certified and follows ABYC and ISO standards, which ensures a high level of safety and quality. Each boat also comes with a 10-year structural hull warranty and is paired with Yamaha's Power Match system, providing owners with peace of mind while on the water. The YS-53 by Damen Yachting is an all-new yacht support vessel, specifically crafted to meet the needs of adventurous yacht owners. With its robust design, the 53-meter yacht offers exceptional storage capacity, durability, and high performance, allowing it to take on challenging global explorations. Its new naval architecture draws on Damen's 2 decades of yacht support experience, merging functionality with advanced technical solutions. Capable of reaching a top speed of 19 knots, the YS-53 supports up to 10 crew members plus the captain. Damen has already begun construction on the next 2 hulls, with delivery set for spring 2025. Azimut Bonetti, based in Avigliana, Italy, stands as a leader in luxury yacht production, symbolizing Italian excellence in engineering and design. Known for yachts that can exceed 30 meters, about 100 feet, in length, the company has pioneered cutting-edge methods like vacuum infusion, a process originally adapted from Scandinavian techniques. Vacuum infusion allows for the production of lighter, stronger laminates by stacking all fiberglass layers at once and using vacuum pressure to distribute resin. This results in a thinner, more efficient hull. The recently launched Sea Explorer 58 yacht is now set for its final build phase, preparing for delivery in the coming months. This custom-built vessel, designed in partnership with Design Unlimited, offers a seamless indoor-outdoor living experience for adventures worldwide. Accommodating up to 12 guests and a crew of 15, it includes luxurious suites and an array of exploration gear, such as tenders, motorcycles, off-road vehicles, and a custom sailboat. Guests can relax in the cabana-style bar and infinity pool, while a helideck and bow observation lounge provide panoramic views. Sea Victory is a chemical, oil tanker built by Hyundai Mipo Dockyard, Ulsan, South Korea. Its gross tonnage is 29,348 tons. Thenamaris Ship Management Inc. Athens, Greece as its manager. Thenamaris Ship Management chooses to award Odessos Shipyard for repair work to Sea Victory. Odessos Ship Repair Yard is the largest and best-equipped Bulgarian shipyard for docking of vessels up to 90,000 DWT and afloat repairs up to 150,000 DWT. Relying on its solid base, excellent organization, highly qualified personnel and rich experience, Odessos has established as one of the leading ship repair yards in the Black Sea and Eastern Mediterranean area. Steel Workshop is well-equipped and carries out all kinds of repair works and conversions. Experienced specialists perform successful repairs and conversions too. Shell plating, various hull structures and units, double curvature fore ends and aft ends hatch covers, boilers, reefers with all specificity of heat insulation in holds. Blasting and painting workshop carries out all operations on hull cleaning and reconditioning as well as fuel tank cleaning. Grit blasting to SAW 2, 5 according to the Swedish standard. Water blasting up to 2,500 bars. Application of various protective coatings, including silicone anti-fouling coating and painting. Odessos offers a complete applying of advanced fouling control coating with high solids content silicone paint and repair of already existing one. The technology for repair of already existing silicone-based paint coating is the same as laying an entire new one. In order to precisely apply the coating, they strictly follow all the requirements of the producer of the paint. Odessos Shipyard had already applied silicon-based coatings of all the famous producers of silicon paints: Hempel, Sigma, International, Jotun and others. Odessos Ship Repair Yard is spread over an area of about 320,000 square m, equipped with 2 floating docks and 1 graving dock. The total length of berths is 1,953, 5 meters with an average depth of 6.35 meters. The depth of the port varies from 5.30 meters to 9.80 meters. Odessos Ship Repair Yard has 17 cranes. The graving dock is equipped with 1 30T crane, 2 15T cranes and 1 10T crane. Floating dock number 2 is equipped with 2 15T cranes and floating dock number 3 is equipped with 2 20T cranes. Also available is a 100T floating crane.
Offshore pipeline construction is a complex engineering process requiring advanced machinery, skilled personnel, and precise planning. The process begins with a detailed seabed survey using sonar and GPS mapping to determine the best pipeline route, avoiding obstacles and unstable terrain. Once the route is confirmed, high-strength steel pipes are manufactured, coated with anti-corrosion materials, and transported to the offshore site. On-site, specialized pipelay vessels assemble and deploy the pipeline using one of 3 main techniques: S-lay for shallow waters, J-lay for deep waters, and reel-lay for rapid deployment. Each pipe section is welded, inspected, coated, and gradually lowered onto the seabed. For added protection, pipelines may be trenched and buried using plowing or jetting techniques. After installation, remotely operated vehicles, ROVs, conduct inspections, checking for structural integrity, leaks, or misalignments. Pressure testing ensures the pipeline is ready for operation. Throughout the construction process, a highly coordinated team of engineers, welders, and machine operators works alongside automation systems to maintain precision, efficiency, and safety. Offshore pipelines are essential for global energy transportation, ensuring the efficient and secure delivery of oil and gas while minimizing environmental risks.
The making of a forged ring starts with a heated steel billet, glowing intensely as it emerges from the furnace. That first burst of color instantly conveys the sheer energy stored within the material. It is almost hypnotic to watch raw metal radiate such strength before shaping even begins. The billet is transferred to a powerful press, where immense force flattens it into a disc. The controlled compression ensures uniform density, critical for the integrity of the final product. Each thunderous strike echoes with the determination behind industrial forging. Next comes piercing, where the center of the disc is opened to create a hollow shape. The piercing tool drives through the hot steel, forming the initial hole that will later define the ring. At this stage, the transformation feels bold, as the steel resists but yields under relentless force. The hollow blank then moves to the ring rolling mill. As the rollers rotate, the ring expands in diameter while its wall thickness becomes more refined. The sight of the ring growing larger with every pass carries a sense of unstoppable momentum. This rolling process achieves not only the required dimensions but also enhances the mechanical properties of the steel. After rolling, adjustments are made for roundness and uniformity. The glowing ring continues to turn until the desired measurements are reached. Watching the circle take on its near-final form sparks an appreciation for the balance of power and accuracy. Finally, the forged ring is left to cool under controlled conditions. Strength, durability, and geometry are now locked into the steel. What began as a simple billet has now become a robust ring, ready for demanding applications. Massive gears are born here through techniques shaped by both power and skill. Bruck GmbH employs 4-gear milling machines to handle demanding requirements. In peripheral milling, the gear blank rotates continuously as a spiral-shaped cutter forms teeth, achieving quality grade 9 for heavy-duty use. These wheels may reach 7 meters in diameter, with teeth up to 90 millimeters. Profile milling works differently. Each pitch is indexed and milled, even angled up to plus or minus 30 degrees, producing reliable gears for wind turbines. The scale of this gear case commands attention, its bulk setting the stage for demanding machining. Namco Machine and Gearworks Limited undertakes the task with determination. The case is mounted securely, and powerful mills trim surfaces to exact alignment. Line boring follows, guiding tools steadily through the housing to ensure perfect shaft passage. The rhythm of the cutting tool feels intense, almost alive. Each pass deepens the accuracy, and soon the structure is ready to endure heavy industrial loads. The production of a PDC drill bit begins in a workshop where raw materials and technology intersect. These drill bits are vital tools in oil and gas exploration, designed to cut through rock with strength and consistency. Each stage in the process shows how engineering skill transforms basic components into something with immense power underground. The first stage involves preparing the steel body. Solid steel bars are cut and shaped into cylindrical forms that will serve as the backbone of the drill bit. Welding equipment and lathes are used to refine the structure, ensuring that dimensions meet strict specifications. It is fascinating to see how solid metal is gradually guided into the required form, as though the material is submitting to both heat and mechanical force. The glowing sparks during welding add intensity to the scene, reminding us of the strength being built. Once the body is prepared, the focus shifts to creating blades. Alignment is critical here, since even small errors would affect the stability and efficiency of drilling operations. At this stage, the drill bit begins to resemble the powerful cutting tool it is meant to be. There is a moment of anticipation as the structure finally looks like a tool ready for its role. The process then moves to finishing and balancing. Surfaces are ground, cleaned, and coated to protect against corrosion and wear. A balancing machine ensures that the bit rotates smoothly under extreme conditions. This part of the process highlights the remarkable mix of physics and craftsmanship behind drilling technology. Finally, the drill bit undergoes quality control. Inspectors check welds, alignment, and cutter placement, verifying that the finished product meets performance standards.